All right, to help you with graphing, since we didn't get to do a ton of examples, let's look at some of these problems that we were doing at the end of class to get you going here. This one, if we look at the formula again, this one has a vertex of 0, -4, and an a value of 1. So to help you with figuring out how to graph, with a little bit more practice, what you're going to do is plot the y-intercept, or sorry, not the y-intercept, the vertex, which happens to be the y-intercept also, 0, -4. And then we're going to use our slope. Remember, a is your slope, so you can think up 1 over 1. So that's the right side of your graph. And then, remember, absolute value graphs have symmetry, so then you can just reflect those points and go up in the other direction. So that would be your graph for that first problem. Oh, they renumbered. All right, this one has a vertex of -1, 0. And the reason is because it's always whatever's being subtracted. So you could rewrite this as x minus -1, which means your h value is at -1. Your a value, there's an imaginary 1 there, is also 1. So for this one, you have -1, 0. That's your vertex. And then use your slope, up 1 over 1, up 1 over 1. And then reflect it. Remember, your line of symmetry goes through your vertex. For this next one, the h and k values are 0. Nothing was being subtracted from x and nothing was on the outside, but your a value is 1/3. So here, your vertex is 0, 0, and your slope is 1/3. So up 1 over 3. Up 1 over 3. See how it's growing more slowly? And then reflect that. Up 1, back 3. Up 1, back 3. This one has a vertex also of 0, 0, but an a value of -5. So that tells us we know it's going to be facing downward. Zero, 0. So this time, go down 5. Remember, it's -5 over 1. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 over 1. And then these are kind of hard to connect with straight lines. And then reflect it. 1, 2, 3, 4, 5. So the negative part is what makes it face down, and the 5 is going to be your growth rate. I hope that